Alright, hello and welcome back. We are pretty much done with these slides on loops, and we have gone quite far, I think. We've talked about while loops, infinite loops, for loops, those are the main ones, nested loops. Those were difficult, and we're going to practice that some more before we finish these slides, okay? So what we're going to do now is graph a circle on the terminal, and it's a bit involved, but it's going to be a good example because it's going to help you do your lab. So we're going to pretend that our terminal screen, and we don't really have to pretend, it's kind of true, it's just like a box, right? It could potentially be filled with as many characters as it is wide and as it is high, okay? So you could imagine filling your entire terminal with stars, just one big box of stars. And that's essentially what we're going to do when we graph things. We're going to pretend that the very middle of our terminal, so it has some width and some height, the very middle of it, whatever that is going to be our 0, 0 coordinate, okay? And we're going to graph a circle of a certain radius using characters. So we're going to figure out that, alright, maybe this is 20, 0, 20. And that's part of a radius 20 circle, and we're going to draw that using just plain characters, so just enough stars to make it look proper, okay? That's going to be what we're going to do, okay? And the way that we'll make this work is that, well, we know the width and height of our terminal. We can figure that out, or we can just set a sample value. So here is my terminal, and you can see when I rearrange it in the middle, it's showing how wide and how tall it is. So it's 88 characters wide by 22 tall, and so we can pick a normal one. I think when you open up a brand new one, the default width and height is 80 by 24. So maybe we can play around with that, at least 24. Okay? So that's what we'll do. And let's see how big mine is right here. So let me set it at 80 by 24, and let's play around with this. Okay? So width is going to be 80, and height is 24 characters. So if I want to fill this up with boxes, or fill this up with a bunch of stars, just make one big box. And I'm sorry, my 4 is not the best today. There, that's a 4. What we'll do is we can print 80 stars, and do that 24 times. So let's make one big set of boxes. So I'm going to go into our CSCI 40 folder, and you know what? Maybe I can make this one giant like we're used to it. That'll be okay. CD CSCI 40, and let's make a folder for today. Go inside of it, and here we are. Alright, so I'm going to make a file called circle.cpp. So the first thing that we want to do is let's fill the terminal with an 80 by 24 grid of stars. That's something that we know how to do already. We can use for loops. For int I equals 0, I is less than something, I plus plus, for int j equals 0, j is less than something, j plus plus. And now we need to figure out what I and j should range between. So if we remember that the outer loop from our box example keeps track of which line we're on, well, that means it deals with the height. So 24 should be how many times that executes. Okay? And then that means that this one worries about the current line, which is 80 long. Okay? Or so we're saying it's 80 characters long. Alright, so now I can just print out that star, and now this entire for loop, once the inner one has been finished executing, we've printed 80 stars. So we've completed the line with this inner for loop. We've printed 80 stars. And so now our job is to break that line after it's done. Get ready for the next line. So it's just a repeated process. So 24 times we're going to print 80 stars and then a new line. Okay? So now when I go and run this, I'm going to actually get out of my Vim and do it in this terminal, this big one. G++, standard, C++, 17, circle.cpp-o circle. And what do you know? This is 80 by 24 of stars. That's what's happening there. Okay, and you can count it, and when you make your own normal terminal now, and that's the default, if you go and run it there, it'll fill it up entirely, and it'll actually it'll fill it up a little too much because it'll give you that next terminal prompt, because that takes a line. So we filled it up, 80 by 24. Isn't that cool? Okay. So maybe I'll make mine 80 by 25 so I can see all of that at once. Okay. So now our job is no more stars, but let's pretend that this is a coordinate system. Okay. So we need to find the middle, and that should be our 0, 0. So right now it's more like, I don't know, 12, because that's the line on I is 12, and then j is like 40, but we want the middle to be 0, 0 instead of like 12, 40. Okay, I hope you see that. Dun dun dun. So currently, the middle is I equals 12, and j equals 40, because that's half of each of these, half of the width, half of the height. We want that to be 0, 0 instead, okay? That's what we want to work on right now. So notice how I, which line we're on, is kind of like the y coordinate, okay? So I is like y. I is like y, and that means j is like x. Because when j is equal to 40, we're in the middle here, and that's the x value. It's keeping track of how far along this horizontal line we are. Okay? So I is like y, j is like x, so let's change them. I hope this process is making sense. We're going through it really slowly. Alright, so now I have things that are y and x coordinates. Okay, so in here, I want my xy coordinate in here to make sense. I want it to be 0, 0 when it's in the middle. Okay? And so we're going to have to change what y and x are allowed to be between. When it's up here, when we start y, because that's the very first thing, we want y to be not 0, as it is right now. We want it to be, I guess, either 11 or 12. We want it to be like, let's have it be 12. Why not? We can just extend if we needed to. So y should be 12 up here, and it should be negative 12 down here. And that'll allow it to be 0 in the middle. Do you see that? So this is what we want. And if this is the starting value, that means y needs to start at 12 and end at negative 12. Okay? And really we need to pick one that needs to be 11 because it's not exactly 24 things. But we'll keep it like this. It'll be actually 25 lines. Who cares? Okay? So what we just discovered is if we want y to function like the y coordinate, y needs to be 12 here. Then it needs to decrease as it prints out line by line. It should be 12, 11, 10, all the way to 0, because that'll let us hit 0, 0 in the very middle of the screen. Okay? So y minus minus, and now x is very similar. So when x is right here, we want this to be x equals, I don't know, negative 20, right? Because we want 0 to be right here. So this should be negative 20 and, oh, sorry, negative 40. And this should be positive 40. And again, this is really 81 numbers. We'll just change the size of our terminal. It's not a big deal. All right, so negative 40 to positive 40 is what x should range between so that it becomes 0, 0 in the very middle. Okay, I hope you see that. So, dun dun dun. All right, so x should range between negative 40 and positive 40. Again, if you wanted to be precise, you'd have to pick one to be 39. And x will increase still. Okay? So now, to check ourselves, let's print the plus sign, the axes meeting, at 0, 0. Okay? So when we're in the body of this inner loop, we have an x value and a y value, and we have just changed them to be like coordinates. Okay? So if x is equal to 0 and y is equal to 0, let's print, instead of our star, let's cout plus. Okay? The axes meeting. And otherwise, we'll print out our star. How about that? Okay, so if we're in the very middle and we did it right, we'll see a plus sign. All right? So let me recompile. This needs to be one wider and one taller, but that's okay. And what do you know? And I can prove that to you by dragging this a bit bigger. What do you know? Right here in the very middle, we have a plus sign. You see that? That's beautiful. That's exactly what we wanted. And now we want to graph a circle around this. Okay? So let's talk about how we want to do that. And right now, let's first replace the star with empty space. So just a space character. Here are our axes meeting. Okay? We can draw the lines, and you'll draw the lines in your lab. Okay, we're almost there. So we have our coordinate system set up, and we have changed the way that our loop works, the way that its variables increase or decrease, so that we have coordinates that make sense. And now it's our job to graph a circle. So if this is 12, this is 0, maybe let's graph a radius 10 circle. Okay? Let's graph a radius 10 circle, and if you remember from algebra, we want to graph the function x squared plus y squared equals 10 squared, so 100. Okay, so that's really 100. So we need to determine whether or not our current coordinate is part of the graph. Okay? And you thought algebra would never be useful. So we've chosen the equation x squared plus y squared equals 10 squared to graph. Okay, so we need to figure out, in order to graph it, we need to determine which coordinates are part of that circle. So which coordinates are part of that circle? Let's get rid of that. Well, they are exactly the coordinates for which this equation holds. So as long as I can figure that out, I know where I'm graphing. Okay? So we'll just check our current xy coordinate, because we consider a different xy coordinate each time. As we walk through our graph, we look at this one, whatever coordinate it was, see if it's in the graph or not. If so, we'll mark it as on the graph, or we'll just print a space, or potentially we're in the middle right now, we'll put a plus sign. That's the idea. We're walking through, we're trying all the possibilities of every xy coordinate. That's what a nested loop gets us. Okay? So if we just so happen to have our current xy coordinate respect the equation, and print like a star or something if it's on the graph. Okay? Because that means if it matches the equation, like this holds, that means we should have plotted it. It's on the graph. Okay? And it's going to be fun to watch this work, I promise. We're building up to it slowly. Now, it's not good enough to do what we have so far, because x squared plus y squared equals 10 squared, that has a lot of solutions that are not whole numbers. And remember that every coordinate that we consider is a whole number. Okay? A pair of two whole numbers, two ints. So we need to somehow kind of squash the solutions to this equation onto the graph, onto whole number parts. Okay? So it'll look a bit different, but still very close to a circle. So what I'm first going to do is solve for y. Y equals plus or minus the square root of 10 squared minus x squared. So this is the graph in two different forms, so we'll have to worry about the plus part and the minus part, but that's okay. Let's worry about the plus part right now. So let's pretend we have an xy coordinate and we want to check if it's on the graph. So I have my x, I have my y. I'm going to compute this value. So I will go and figure out, does y equal square root of 100 minus x squared? Okay, I'll go and check this, but it might not be a whole number. So I can round that. That's the key. I'll round all of that, and then it'll be set to the nearest whole number. Okay? And this will be how I graph. Okay? That is the key right here. This is how we squish the correct values onto whole number coordinates. So this is very in-depth, and you're going to be graphing much simpler functions in your lab, don't worry. Just one. So that's the idea. We need to just check if it's on the graph. If so, print a mark. Alright, so I'll include CMath. And now is the moment we've all been waiting for. If it's on the graph, I'm going to print maybe a star character, and then this will be an else if, let's say. Dun, dun, dun. There. Okay. So now we just need to figure out how to check. And it really is just checking for the equation that we found. Is my y currently equal to the rounded form of the square root of 100 minus x squared? So we just solve for y in our equation. And remember that round will give us a whole number, so this will work out, and we can compare for equality. If it's close enough, graph it. Because maybe it was, I don't know, 3.5, 7.5 instead of 4, 8. And we'll just find it. It's okay. Okay? Are you ready? So I'm going to run this, and then we'll walk through it. It just printed the top half of that circle. It's squished because of the way that our coordinates go, and you can fix this yourself. But we're checking, like we're considering this coordinate right here has a certain x and y value. Is it very, very close to where it should have been? Is the square root of 100 minus x squared, rounded that to the nearest whole number, is that equal to y? That would tell us whether our current xy coordinate that we're trying to either graph, figure if it's the middle, or just leave alone, is that something we should consider. Okay? So this is the equation that checks if it's on our graph. Okay? So that's the positive one, and we've drawn half of the circle. All we now need to do is graph round of the negative square root, because we needed that other one. We need that other side. Else if it's there, we'll also see out. And this one is very similar, so oops. It just needs a negative sign. Okay. That's all. And so now this will be the bottom half. Okay, check if it's on the bottom half of the circle. Alright, are you ready? Because I think we have a circle now. So for every potential x and y coordinate, we check, is it on the graph? Close enough. If it's not, we'll print a space. But if it is close enough, we'll print that star. Or we'll also print the plus sign to show the axes meeting. That's the middle of the graph. And so we can play around with this. We can stretch it out if you would like. We can make y range between, like, not 12 and negative 12, but maybe 6 and negative 6. We can have it, for example. I don't think that'll work because of the tens. We'll have to figure this out somehow. Or, sorry, the x's. We can change that to be from negative 20 to 20. And I'll just shrink, that'll expand our graph horizontally. And we'll have to use doubles for x now, because we want it to increase by 0.5. Oh goodness, why? Don't know why I wanted to do that, but that's, I guess, what we get. And now it's expanded. It looks more like a circle to me. But that's the game. It's beautiful. We consider our current x and y coordinate and see if it's close enough. Okay? And I think that's all I wanted to say there. So you're going to be graphing much simpler functions, but you're also going to draw the axis lines. And I've mostly set up this for you in your lab. So you're mostly going to work on this middle bit. Okay? So I hope that that's fun. I think it's super cool. And it's not too bad now that you've seen it once. Okay? So we're just figuring out whether or not these coordinates are on our graph. Alright, so now here are some exercises for you. And the first one is change this into that flowchart form like I showed before. So maybe there's some stuff happening before, then there's some stuff happening after. This will help us to understand how these loops are executing. So before always happens first. Assuming you pause this and you tried it yourself, before always happens first, and then the first thing we do to execute this whole thing is worry about the outermost thing, which is the while loop, which will check its condition. If it's true, it'll start executing its body, and that body just so happens to be a for loop. So we'll execute the for loop now, which checks its, which does its initialization, it's B, then checks its condition, C, which is fun, but that came out like that. If that's true, it does its body, E, and then it goes and does its update statement, D, after the body's finished, and goes straight back to checking that condition, because the initialization only happens once. And then if it's ever false, if C is false, we're going to go back to check the while loop's condition again, because that means that this for loop is complete, which means that this entire body is complete, and after a body of a while loop is done, we go back and check the condition again. Okay? Now if this original while loop's condition was ever false, then we're going to finish everything. We're going to go straight to after, because that means that the whole while loop is now complete. Okay? Now finally, that inner for loop, I gave you a true state and a false state, and yeah, that should do it, actually. I didn't notice that I wrote the F over here, but yeah. In the true case, we're doing that. In the false case, we're doing that. So we see our little inner loop, and we see our big outer loop. So we're kind of going like this, and then like that. Okay? Which is fun to think about. So this is the kind of idea that I want you to have in your mind. Maybe you don't have to recreate this, but just know how these are executing. Okay? Another very nice exercise for you is to write 4 different kinds of infinite loops. Use while, use for, use nested. Just make as many mistakes as you can so that you remember how that happened and how to fix them. Okay? That's super helpful. Usually it's missing an increment, that's the problem, or maybe the check, the condition was the wrong way, maybe it was greater than when it should have been less than, things like that. Those are normal problems that I've seen before. And then finally, write a program to find the first n, so the first number n, so make n range between some values, greater than 100, where n to the third plus n squared plus n plus 1 is divisible by 555. All right? So you're going to have to make n range between some numbers, and it'll start at 100, and then it'll just keep going until you find the first number. Okay? And then with that, we have reached the end of these slides, and I want to talk about the midterm now, okay? Because that will be happening on week 6, okay? Yeah. So let me go to the midterm page. All right, so yours is going to look quite a bit different than mine, because I have all these starter things, but this will just immediately appear probably below this week. You'll have this thing called midterm 1, okay? And let me go to the info page. So this is what's going to happen. The midterm will be available on Canvas between September 17th and September 18th, between these times. So I will have 2 office hours in between these. Okay, you can come to either one if you ever want to ask me questions, or if you want to take it in the middle of the night, you can do that, okay? So that is, that 17th is a Thursday, and the 18th is the Friday, all right? So between those times, you can take the exam. Okay, you'll take it on Canvas, and you'll click Start to take the exam, and you'll have a normal class period of time, an hour and 15 minutes to take it. Okay, that is the idea. So you better start before 4:15 on the 18th if you start it that late. Okay, because you need that entire time. All right, so it'll take place during labs. So I'll give your next labs starting that week some extensions. So I won't be a horrible person and ask you to complete a lab as well. So that's the idea there. And here are the topics. That's probably what you're most interested in. So I will include the topics from the lectures through week 5, just simple things for arrays and vectors. Those are going to be the next concepts. You might see something on those, but very minimal. I'm going to hit hard this stuff. All right, so your Zybook readings and your Zylabs from chapters 1 through 4, because that's going to be due on week 5. And then also labs 0 through 3. Those will be where I'm taking my questions, okay? And the format of the midterm is going to be this. So it will start, it'll be like 2 halves almost. The first half will have multiple choice questions from the textbook chapters. So chapters 1 through 4, making sure you read those. And then after that, it's just a free-for-all. So fill in the blank / coding questions taken from all these topics up here. Okay? And I'm going to ask you to submit code in like a Canvas text box. So please practice copying and pasting from wherever you're typing your code. Okay? Make sure that it's ready to go. And yeah, with that, the test is, of course, open book, open notes, but not open chat app. So you can't be talking with people. And if, yeah, you don't want to know what happens if I find out that something like that happened. All right, so that is the first midterm. Hopefully it all seems fair, and that's what's going to happen. So, of course, I'll have some reminders for you around these times, but plan for those days, okay? You can take it within, it's an over a 24-hour range, all right? So yeah, just prepare to put code into a Canvas text box. And then finally, your first extra credit I have made. So I would like you to create a study guide. This will help you study for yourself and for your peers. So it is a crowdsourced study guide. Let's go to that. I hope that it will be helpful. And so if you click here, there's a lot of requirements. So please read those if you're trying to do this. But here are your options. You can create a question for your peers to answer. Like, this is going to take the most work. So you can create a question that might appear on the midterm. So think about the topics, come up with some good questions. You can make multiple as long as it's 400 words. Okay, that's going to be your submission. You'll click reply down here, and it'll be a top-level submission that will hold your question. All right, and then you'll also post a very quick answer 3 days later. See the write-up there. And you cannot answer your own question otherwise. You can't do this option on your own question. You have to post your answer 3 days later. That's part of this first option. Okay? And so that is 1% extra credit, which is like worth a lab in a sense, something like that. And then, let's see here, or maybe half a lab, something like that. And then you have option 2 as well. You can answer a question that was created by somebody else. Okay, so you can respond to your peers. There'll be a reply button on their question, and just write 250 words, including code, of an answer that's very well explained, things like that, and that will be 0.5% for extra credit. So you can do either of both of these options as much as you want, up to 2% extra credit. Okay, so you can make 2 questions, you can answer 4 questions, or anything in between. Okay, up to 2% extra credit. And that's what I want to talk about there. For the question makers, though, I do want to highlight that your questions should be reasonably challenging. Don't make a bunch of super easy questions. Don't copy them from the Zybooks or something like that. I want you to take some effort on this. This is extra credit. Okay, so shouldn't be super easy. And then also, if you're answering a question and somebody else has already answered that question, you better add to that discussion, okay? Don't re-answer a question without adding anything. All right, you must add to the discussion. Let me say that instead. And I talk about in the write-up how you might go and do that if somebody's already answered the question and you want points. Okay, so that is your extra credit option, and I hope that it will help you study for this midterm. If there are some good questions, I might include them. Who knows? So yeah, that is the midterm. That is information about the midterm. It'll be, assuming you're watching this during week 4, it'll be two weeks from now. Okay, so with that, I will get ready for the next set of slides and come back. All right, welcome to the next set of slides. This won't take very long because we don't have a lot of time left, but I'll get us started, and then we'll we'll continue this next week. So arrays and vectors are very fun to talk about. They let us deal with a lot of data at once. Okay, so just as a heads up, these slides are going to teach us how to hold stuff. Right now, normally we have a bunch of little tiny boxes that hold our stuff. Strings are the one exception. They can hold as many characters as we ask them to. That's the one exception that we have, but what I'm about to show you is how to hold a bunch of ints at once, okay? Things like that. So I do want to give you a heads up that vectors are much better than arrays. We would always want to use vectors when we can. And when you can't is maybe you don't have, maybe you have some timing requirements for your program, like you're writing the program that makes a pacemaker work inside of somebody's heart, and you don't want to wait for memory to be allocated. That's when an array would work better. And then also multi-dimensional arrays kind of just make more sense than vectors. But that is probably all beyond the scope of this class. Just if you get nothing out of this other than, if you get nothing else out of this set of slides, use vectors as often as you can, okay? But first we need to talk about arrays because vectors are more complicated. All right, so arrays allow us to hold a bunch of stuff of the same type. If we wanted to ask the user for 50 numbers, for example, and print them back out, this is how we would do it. We would declare 50 ints, and then we'd see in all of them, okay? And then the rest of the program would deal with printing out, outing those 50 things. And that's not what we want to do. We want a better option, and there is one. There's this thing called an array, and your book defines it like this, I think. It's a variable with one name that holds a list of data items of the same type. That's going to be key, same type, each being directly accessible, so you can get to them immediately, okay? And so each item is called an element, and I'll show you that in a second. And directly accessible means that we can index into our array using this bracket bracket operator. It's two brackets together. It's not like a special character that's a very narrow rectangle. Let me do this. There, it's two brackets right next to each other. That's the operator. All right, so this is very similar. It's essentially the .at for strings. It's the same concept. You're just using brackets instead. Okay, so if I say to C++ int arr bracket 7 bracket semicolon, this makes an array of size 7 holding ints. Okay, an array of 7 ints. All right, so arr in memory is going to be this. It's got space for 7 things. 1, 2, 3, 4, 5, 6, and, well, 7. Let me see if I can erase that well. Not easily, but that's okay. There we go. So that's our array. It's got space for 7 things, and semicolon means just make that space, but don't initialize it. So this is currently uninitialized, just like any other int. It's just a bunch of them at once. So I have a bunch of question marks to write inside of here now. Okay? And these indices mean that I can do this. At index 0 holds the first value, at index 1 holds the second value, and so on. Okay, so it goes from 0 to 6, just like strings. Okay? So to declare an array, we want to say the name of the type of the stuff that's inside, like int, double, you even have an array of strings. So you say the type, then you give the name, just like a normal variable, and then you give the size. Okay? That's what you want. And normally it's filled with garbage, so you have to index into it. So let's say int arr of 3. That'll make arr in memory, holding 3 question marks at the moment. If we want to fill it with something, we can set its current index, set a certain index with a value. So we can say arr 0. I would like to make that 1, please. Okay, so this is indexing into the array and setting the 0 here. Okay? Index into the array and set the value. That's the idea. And you can also, it's kind of a lot of work if you want to set all these 3 things at once, and you have to write 4 lines potentially, similar to that one. There's a way to do it faster. You can say type, name, size, and then a bunch of braces, and give everything comma separated between those braces. So we could say instead something like int arr of size 3, make that initially hold, please, 1, then 2, then 3 in those indices. So index, that would make this arr. At index 0 it held 1, index 1 it held 2, index 2 it held 3. Okay? Remember those indices. But, I mean, you already typed 3 things. The compiler's smart enough to figure that out. So you can just leave out the number if you immediately give the values. Okay? So this would be equivalent in this case. Okay? There are times where you would want to both include this and give the values. But that's something we'll get to later. All right? So let's have a demo. Okay, let's get 10 numbers from the user and print them back out. Something simple like that. Okay, so let's go into code. Let me make a file called Do I just want to call it arrays.cpp? Yeah, because we're going to do quite a few things. Arrays.cpp. All right. So what we will do is, well, we need to make space of how many stuff? Make space for 10 numbers. And let's just assume they're int numbers. So I just made space for 10 things. So arr in memory, it's a box with 10 boxes inside. And now I want to populate them with values. So I will get those 10 things from the user. Okay? I can say, enter 10 numbers, please. Oops. And then I can get all 10. I can say cin into index 0, then into index 1, and so on, but this is a prime candidate for a loop. So instead we'll say for int I equals 0, I is less than 10, I plus plus, cin at index I. Okay? So you'll just keep on getting 10 things and putting them into the proper indices in your array, starting with 0 and then going all the way to 10. Okay? So now we have our array with 10 things. Let's print them out. Okay, so again, it'll be a for loop. It's very similar. We can say the 10 things you entered were, and now instead of seeing in, we can see out those things. Yeah? And maybe we'll space separate them. And then finally a new line at the very end. So this will just print back out those 10 things that the user gave us. And that'll be that. No, I don't want to do circle. Sorry. I want to do arrays. And oh man, I gotta type 10 numbers to the user. What shall I type? Well, how about, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, and then it's, well, like, alright, the 10 things you typed were those. Okay, so it filled in my 10 indices with 1, 2, 3, 4, 5, 6, 7, 8, oops, 9, and then 10. And that is what my array looks like. This is index 0, this is index 9. Okay? Let's also get the sum of all these things. Okay? This is a really good example of using loops to actually do work. Okay? Let's get the sum of all those 10 numbers. Okay? So like we did before, we'll just make a variable that holds the sum. And what should it start with? What's the sum of 0 numbers? Well, that's 0. So then we can go through the thing again. For int I equals 0, I is less than 10, I plus plus. Then we can say sum, add into that please. So our sum, I want to make that equal to what it was before, because I'm adding into it more stuff each time, plus my current index into the array. Alright? And then I can print out the sum. And the reason this will work is because we're going to make that sum variable, and we're going to start it off at 0, and then each time we visit an index, because we do that in the body of the loop, a new index each time we visit an index, we will add that into sum. Sum is now 1. Move the index. Oh no, it's all stuck together. Darn. Move the index. Sum is now 3 because we added the 2. Yeah. And then so on and so forth. Yeah, now I can move it. We can add in the 3, and now it'll be 5. And so on forever till we get to whatever that sum is. And assuming we type in the same 10 things, it'll be 55. Okay? So that's how we keep track of something. So we say we're accumulating the result, the summation, inside the sum variable. It changes each time we execute the body of the loop. It gets bigger by the array index we're trying to add it into. Well, technically it could get smaller if we had negative numbers, but you get the idea. So that then once this for loop is finished, that means we've visited every index and we can output the sum. Okay? And then finally, let's get the minimum too. Okay, so what should the minimum value be? This one's a bit more involved. So let's think about this. How do we get the minimum value of all the values in the array? It could be anywhere. It could be right here. Maybe this value is negative 42. Maybe this value is negative 42. So we have to check every index. That's a given, because it could be anywhere. And then, well, if we check every index, what should we be saving? Let's save our current guess for the minimum. Oops. And we'll have to update that guess each time. So pretend that this was really negative 42 right here. Initially, we're pretty confident that our minimum should be 1, right? Maybe this is our min variable, because we've only seen one thing. But the second we start looking at more things, like this 2, well, all right, yeah, the min can stay 1. Yeah, the min can stay 1. Once we get here, though, the min needs to change to 42, because we've seen this far into the array, and we have some new information. And then 42 should stay the minimum, unless later we see something like negative 43. You see that? So we always need to save our current guess, but we might need to update it later. Update it as necessary. So this is kind of different from sum, where we're never checking sum each time, we're just adding into it. We have to check the minimum against our current index each time. All right? So let me prepare to do that. This is what's going to happen now. So the min, our first guess for the min can either be a very large number that we know is not in the array, or it can be the first index, okay? Let's make it that, okay? So our first guess for the minimum is the first value at index 0. And then we need to go through the rest of the array now to see if our minimum should update. Okay? So for int I equals, you can make it 0, but then you'd already have visited array 0. That's already the min. We don't need to change it. Let's start at 1. I is less than 10, I plus plus. So now we need to do some stuff. We need to check and see if our min is still the correct min. What does it mean to be the correct min? Well, it should be smaller than the thing we're looking at. Okay, so if our current min guess is less than the index we're looking at, so for example, maybe it's 1, we're looking at 2, if it's less than that, we can keep the min as 1. Do nothing. Min doesn't need to change. But otherwise, and you can change this into just an if statement with the negation of this. Otherwise, we need to update the min. We have found a better guess for the minimum. Okay? And so we should replace our min guess with the current index. And that will happen if, for example, min is 1, and then we're looking at index 0, 1, 2, 3, and we're looking at negative 42. Okay? In that case, we need to change our minimum. And then finally, we'll continue this process for the entire loop, for the entire array, every other index other than 0, because we started at 0 here. And we'll just keep on updating our guess each time. And it is a true thing, and I hope you, it's intuitively obvious that once we're done with this loop, we have the best guess. We've seen every index, and so we have seen the minimum. And given the way that we changed minimum, if we ever saw a smaller value, minimum will be set to that smallest value. Okay, so we can print that out. Numbers. This one, the minimum never changed from 1. Okay? It never needed to. But if I put something after that 1, if I rerun this program, and I say 1, 2, 3, negative 42, 4, 5, 6, 7, 8, 9, 10, now we're going to start our minimum guess at 1, but once we see negative 42, we will hit this else case and reset that minimum guess. Okay? And so then the minimum will be reset to this value. And we can do this all day long. We could say the final index is negative 43, and that will be the minimum. Now the minimum is calculated correctly still, it's negative 43. And the idea is, because we're visiting everything, every index into this array that holds a bunch of values, as long as we visit each index and update our minimum guess appropriately, once we've visited everything, we've got the correct answer. Okay? That's the idea with that one. And I encourage you to try maybe the maximum now. It should be a very similar process. And so the sum, maybe do the product, what needs to change. All right, I think the last thing that I want to talk about today is this thing called undefined behavior. And arrays, this is the first problem with arrays, probably the most obvious problem. If I have an array and it has size 5, which means it has indices 0, 1, 2, 3, and 4, 1, 2, 3, and 4, you can still ask it about index 5, which does not exist. You can say cout array at index 5. You can see into it as well. This place is memory that you do not have access to. Memory that doesn't belong to you. And C++ thinks you know what you're doing, so it'll do this for you. It thinks that you know the correct size of the array. But when you don't, this is going to be an issue. So it'll probably work. You probably have access to this memory. Maybe it stores a value that's another variable in your program. Maybe it stores something else that's important, but not too important. But once you do this, you invoke the wrath of this thing called undefined behavior. And you broke the rules of C++, and now the compiler, if it ever notices that you did this, it's allowed to change your code to anything because this is undefined. It can be whatever it wants to be. So the compiler is legally allowed to replace your code with equivalent code that just goes through every cat picture on your hard drive and deletes it. Okay? It can do that if it wants to. That is part of the C++ standard. It would allow that. Okay? So please watch out for this. Let me do that. And just, in all caps, never ever do this. And now I'm going to show you it. Oops. Cout ARR index 10. So only goes to index 9, remember, because it's a size 10 array. And it's going to warn me. The compiler is going to warn me. But it will compile it still. 10 numbers. You can do those. Doesn't matter. It got this value. It just read memory that was after the array, and it got that value. You could even change it probably. And I don't know what this is. It depends on the compiler. don't mess with it. That is called undefined behavior, and it will be the source of a lot of problems for you. I am sorry about that, but you'll get good at noticing it, I hope. And that is where I want to leave us today. We have talked about many things. We have studied loops in a very complicated way. We are now ready for our lab, and we've gotten through this bit of arrays so far, and we're pretty much done with them. So we'll pick this up next week, and we'll continue with more arrays. All right, see you next time.